Hello everyone. Today we are going to start our second practical. So we have already conducted the first practical completed, and you have participated in this first practical, and there we actually observe that uh, transistor function and also a variable resistor. Uh, Resistors and the function of resistor and variable resistor and the transistor function, right? So I remember some of you have not participated for that practical, but don't worry about that because today we are going to do our second practical, and there um, I hope to cover all the practical aspect that you need to complete your first practical also. I think one or two students of you could not participate this first practical. So therefore, and I'm going to conduct this second practical by keep in mind that some of you was unable to participate in the first practical. So therefore, you don't worry about that. So you pay your attention sharply, and then you can conduct the first practical by yourself, right? In the second practical, so we are going to familiar with another passive component, that is capacitor, right? So there are two objectives. One is observing the function of a capacitor resistor product. That means the time constant that we explained in the theory class, that resistor and capacitor combination can provide us a kind of timer circuit, right? So then the time constant can be given as time in second when you use the capacitance in farad and resistance in ohm, right? And we have now today we are going to use these different combinations of capacitors and resistors, and then try to observe the time function, right? And the second one is observing the concept of digital versus analog signal, right? So in digital signal, you know that there are two status, on and off, 1 or 0. And analog signals, we have a large number of position in their signal, right? That is a discrete amount of position, right? So we are going to build this circuit, and then we are going to observe these functions. So first we have to identify the component. So the activities, under the activities, identify the components provided and read the color codes of given resistors. So we have practiced how to read the color code, and I asked you to purchase these items, and I hope that you have everyone has purchased these items, and some of you uh, are having issues sometimes. So some of the components you couldn't purchase, but don't worry about that. This video is available to you, and then therefore you can later time even you can carry out this practical in a later time, right? So first identify your resistors, and as you may remember that so I'm going to switch on the video, and I'm going to demonstrate you the components. This is breadboard, so I'm going to show you the identification of components today. So for instance, this is a resistor. So as I explained to you, so then you can read this. So first you have to hold this, the gold color band near to your right hand side when you hold this one, and then you start reading from the left to right. Leftmost band is brown here, that means the 1, and the second one is red. Red means 2, and the third one is actually orange. So that means this is 12K. The third one is the multiplier. So therefore 1, 2, and 3 zeros there. So therefore this is 12K resistor. Like that you have to read your color codes one by one. And then the other new components that we are going to familiar with is the capacitor. Here you can see the capacitor. This is electrolytic capacitor because dielectric material we used inside is dielectric liquid. So this is electrolytes is there, electrolytic liquid is there, therefore this is electrolytic capacitor. And electrolytic capacitor, you can see that this you can see a 470 microfarad capacitor value, right? 470. And also you can see 16 volt here. That 16 volt express that the tolerance limit. That means what is the voltage value, that maximum voltage value that this can bear, right? So that means if you are going to handle like a 9 volt or something like that in your circuit, this is okay, right? So because 9 volt is less than 16 volts, so therefore you can handle about 9 volt in your circuit when you have 16 volt, right? 12 volts also possible, but we usually use we have to keep little bit the tolerance value away from the voltage value that you are using in your circuit, right? So therefore, for instance, that you will never going to use this 16 volt capacitor where you are when you have 24 volt or something, 18 volt or something higher voltage value handling in your circuit, right? So this is that. And then there are other commercial details are there, brand name and temperature value tolerance. So those are not very much important in this stage. And then when when you see that there are two terminals, one is little bit shorter than the other one, right? Two terminals. This short terminal is actually the negative terminal, right? So negative mark is printed on that side, right? The positive side, there is no mark, positive mark, but this short one, and this is negative. So therefore, you can identify correctly this. Usually, electrolytic capacitors, you have to fix considering this negative and positive polarities, right? Okay. This is the new items that we want to familiar with. And identify the components provided and color code. So you read the color code and then identify capacitor terminal, negative and positive. So then we have to mount the circuit and observe the operating time of the bulb by changing combinations of R and C values, right? So we are going to construct this circuit today and have different combination of resistors and capacitors. Actually, I explained this function in the classroom theory classes. So let's try to build up this circuit. And before we are going to build up this circuit, I think it is better to explain you a little bit about, remind you, actually I have already explained this, remind you again about breadboard, right? How to use breadboard for assembling these circuits. So today I have this breadboard that we are going to fix our circuit. So hope you remember I explained you how the configuration of this breadboard. So today I have special breadboard, because I remove this the sticker, and then you can see these metal rings, right? This is a usual one that you have bought, I think you have with you. And this is, I remove this sticker there, right? And this then you can see these metal rings, right? And then you can very well understand that how this connection are established in breadboard, right? So actually even you can separate these your parts, right? You can separate this, and then it will be very easy to understand this. You can see some grooves are there, and you can press this to lock this, and when you can pull this and remove, and have separately these different sections, right? So then you can understand that how these connections are established, right? So here you can see that in this one, you can see the there are two metal rings, right? Metal plate. This one metal plate, it is all the way come here until right until this position, right? That means 1, 2, 3, 4, 5 sets, right? These 5 sets, you can see until these 5 sets, there is a one single metal ring, right? One for this line, and another line, metal line here, right? So that means these connections are internal connected until there, right? This one is also connected until there, right? These connections are like this, right? Right. So let's look at this one, middle part. You can see that how the metal plates are arranged, right? So I'm going to pull out one metal ring, right? I'm going to press this little hard, and you can see that one metal ring has come out, right? So I am going to remove it. Aha. So this is the one inside, right? You can see. Now I am going to show you how we plug our items there, right? So you can see that there are two. It is metal, right? So I'm going to, if when I am going to press this something here, insert into the holes, what you are actually doing, you are pressing this item inside here, right? Like this, right? Connecting this, right? So that means all these are interconnected, right? These are 1, 2, 3, 4, 5. These are interconnected internally by this side, right? Hope you now understood how it is. So all the lines are like this, right? You can see all the lines are here. Now I'm going to fix this back, right? And similarly, each 5 line inside here also the same, right? But the difference here is that uh, all lines are connected together, right? All the way until this fifth sets of holes, right? One set of holes, second, third, fourth, and fifth number holes are there, and then these are interconnected until the fifth one, right? So after that you can see the separation, right? And again we have 5 sets of metal plates, metal sockets again, right? Because there is a separation here, because sometimes we need to use two voltages, right? Maybe 3 volt and 4.5 or 6 or something like that. Therefore that's why this is disconnected in the middle, right? Okay, I hope that you understood very well the inside arrangement of this breadboard. So I will demonstrate you some small things, right? Few things. Then it will be easier for you to understand. Now look at that. How can we connect a bulb? How can we light a bulb? Right? So uh, first of all, I have to fix this separated metal ring here. Yes, okay. So then I'm going to light some bulb. Right? So if I, so we can supply negative and positive current. Positive current and maybe negative current here, right? And so then I will fix a negative current here, negative and positive, right? So then, so I will be able to get negative and positive current. So I will fix it, my bulb here, and using 220 ohm resistor, because there is a breakdown here. So therefore I am going to connect this wire, this bulb with 270 ohm resistor, right? And also I will use another wiring to connect this to this LED bulb, right? So you can see the lighting of this bulb, right? It is lighting, right? So then before you start your practical, make sure that your bulb is lighting, bulb is okay, has not gone, and also all the strings, right? Sometimes these breadboard wires are comes as wires come as broken one, internally broken, right? So therefore check all the wires, right? And by using this, so this is the LED. So LED bulb, you have negative and positive terminal difference here also, right? So the little bit lengthy one is positive, short terminal is negative, right? So therefore when you fix this, now all the positive current is coming in this way. So then you have to plug this positive current into positive line, right? The shorter one, the negative current through resistor, right? So either you can use resistor, usually negative or positive, but usually we can use positive line, so the resistor, and then the other one, I will fix this like this, negative and positive correctly, and then I can check my wires, right? Because you have to there you have this yeah, now it is very clear. Now the negative line is all the way coming down until here. So therefore I am going to plug this negative wire anywhere, here or here or here or something, until here. I can plug it till here, and then I can fix this somewhere here, because the line is disconnected here. You can see the disconnection there, right? The resistor there, and then now I'm going to complete the circuit here. You can see the lighting of bulb, right? So then you replace this wire, few wires, and check whether all your wires are internally okay, without break, right? Without, right? Disconnect all the items, and let's try to start our assembly in the circuit, right? So now I'm going to fix our breadboard again. This is my breadboard again into the normal setup, and now I'm going to construct my circuit, right? So here, this is the battery pack. So you have purchased this battery pack and put these two batteries, and then I prepared a little bit lengthy. The wires comes with the battery pack is not sufficient to conveniently do the operation, so therefore I connect two wires and get the extension. And now I'm going to connect this circuit, right? Construct this circuit, right? So here we can use, I'm going to use here this line for the positive current and this line for the negative current, right? So this is for the positive current and this one for the negative current, right? This one is for negative current. But remember that you should not assemble circuit by connecting this negative positive current, right? Because once first we have to complete the circuit and check again, and then only you have to supply the power, right? So therefore I am going to remove this, and I'm going to use these small wires. Finally I will remove these wires and connect the power supply, right? So I'm going to use this orange color one as a positive line and black color one as a negative line, right? Okay, let's see our circuit again. So this is our circuit that we are going to construct. So before that, I will explain a little bit about the circuit function. Right, here in this circuit, we have 3-volt battery pack and push button switch and capacitor, resistor 1 and transistor, LED bulb and another resistor. Now when you assemble this circuit, we have a push button switch. Once you push this push button switch, then this circuit completes, and this battery, actually the capacitor will instantly complete its charging, right? So because that electrons coming in this way, and therefore electron is accumulating there in this negative metal plate, and subsequently it provide positive charges here. And what you do here is you push this and pull, right? Once you press and release, so therefore when you release back and discharge, this circuit will disconnect because it becomes open circuit, and this charges inside the capacitor is providing electric current through this circuit, right? The circuit that you have resistor, transistor and this circle, this loop, right? So what will happen here? Now after pulling this back, this is going to discharge through this circuit, and let's say that we have 100 charge right here inside, and this is some certain amount of resistance value, 1k resistor, right? Let's say this is 50 microfarad capacitor and 1k resistor, and we have D400 transistor. So this is 50 microfarad capacitor, then it will start to discharge through this circuit. And discharging means so electron flow is there, right? Electron flow in this way, but the positive charges in this way, electric current in this way. So with the time that the rate of flow in these charges, that means the electric current will be reduced gradually, right? Because the charges getting reduced and electromotive force voltage across the capacitor getting reduced. So therefore charges are really neutralizing in this loop here and positive. So therefore gradually this become discharge, right? So when this uh, current through this loop is sufficiently enough to activate the base current, so that you can see the lighting of bulb, right? So once this current, that is, this is like a battery, right? Recharged battery, small battery, right? When all the electrons, all the electric charges circulate in this circuit, and the electron flow will be stopped, right? So when this electric charges sufficiently enough to activate base current, this bulb light, so when it is reached down to very low value, that means so this is the different status of these electric charges. The base uh, terminal um, will receive. So when the base current is sufficiently enough to work transistor in this linear region, you can see gradually reduction of brightness of bulb, right? But the bulb brightness will be reduced in this region, and after that it will off, right? This in this region, when the transistor operate in this region, the bulb will illuminate in full capacity, right? So it is like this. So then what we are going to do, if you use very high capacity like 470 or 1000 microfarad, then it will charge more, accumulate more charges, right? So therefore it will the capable uh, will having capabilities to supply this sufficient electric charges for a long time, right? So let's say this resistor, when this resistor value is very high, so the amount of charges allowing to flow this circuit will become reduced, right? So therefore, this base will activate for a long time, right? So therefore, by increasing this capacitor as well as the increasing this resistor, you can increase the time constant, right? So in this table, we have these different capacitor value and resistor values. In each combination, you have to count the operating time, right? So let's try to assemble this circuit and see the operating time, right? So again, get back to our breadboard. So now we are going to connect this, right? So we will keep the circuit by the side. Right. You see that first we have battery, positive current here, negative current here. We have already fixed positive current and negative current. Now I am going to wire this. So then we have push button switch. But I know that I didn't ask you to purchase this push button switch because probably it is very difficult to find for yourself. But it doesn't matter. We can use two wires and touch these wire ends as a push button switch, right? So first I'm going to wire this one. This is push button switch. This wire is connected, has been connected to this positive terminal. So I am going to connect my push button wire here, right? This is how I fix this connection, this one, right? So then you have another line here. And now I am going to fix it somewhere here. Before that, I can place the capacitor, right? Your capacitor, you have a negative terminal, right? Negative terminal has been connected to there, right? Negative terminal, right? So now I am going to connect this negative terminal into negative current, somewhere like this, right? I will bring this to location like this. Okay, right. So then the other side of the capacitor you can see is connected to the resistor and also the push button switch, right? So the other end is connected to push button switch here, right? This is push button switch. The other positive end is to push button switch. So these two will work as a push button switch for us, right? This is a push button switch. And then this the connect push button switch a wire has been connected to the resistor, right? So the let's use 1K resistor first, right? Let's use 1K resistor. This is 1K resistor. So now I'm going to fix this in. This is capacitor terminal, capacitor wire, and then push button switch wire. So in between this any socket, I can use any socket in this line because these all are interconnected. So now I'm going to fix this resistor here. This is my resistor, and I have to connect this resistor to the transistor base current, right? So it will be easy if we bring this resistor to the upper section, this section. So therefore, I'm going to change this circuit little bit. So I'm going to use this push button switch wire here in there, right? There, and this capacitor and also I'm going to fix this again to this half there, because it is easy for me to complete the circuit in this way, right? Right. Now the same thing, no different, right? Because I'm going to use this line, right? It is easy for me to connect, right? So this is the capacitor there, and we have this connection there to push button switch, and then I am going to fix my resistor here in between these two, right? Then it is nicely done, right? Now you see the circuit. Now follow this circuit. This is positive current is coming here. This is positive current is coming here. This is push button switch. One wire for push button switch. This is this, and the other side of the push button switch. Then you assume that push button switch is in the at the end of these green wires, right? The other side of the push button switch is here, this one. So then it has been connected to the resistor. This is the resistor here. This one resistor, and then the other side of the positive side of the capacitor. This is positive side of the capacitor. All the holes are connected together like this, right? Now we have this resistor here, and now we have to connect this resistor, the other end of the resistor, to the base current, base terminal of this transistor, right? So let's take our transistor. Here it is the transistor. You can see letter printed surface here, D400. When you have this letter printed surface, you can read the terminal as emitter, collector, base. This is emitter, this is collector, this is base. This is the base. So then we need to connect this resistor to the base terminal, right? So therefore what I am going to do is I am going to turn this is the base one, this is the base one. Now I am going to turn this into other side. Right? This is the base one. Right? This is the base one. So now I am going to connect this base to this resistor, right? So now I am going to plug this resistor somewhere here. Right? Somewhere here, the middle, and then this base terminal also to the same line, right? And then I'm going to fix this way. So keep one socket, uh, additional socket in between these lines, right? So it will be easy for you to connect the circuit. Now I have connected the transistor here, right? I've connected the transistor. Now this one resistor terminal has been connected to the base current. Then in the middle you have collector current, and here it is emitter. So then look at the emitter. This is one, the emitter. Emitter has been connected to the negative current. So I'm going to take a wire, small wire, and I'm going to connect this negative current to this emitter, right? This in this way, right? I supply the negative to the this, right. So then we have collector, the middle pin, right? So the collector, then I'm going to turn this transistor here, because so then it will be very visible to you correctly. And then what we need to do is that collector, we have to complete the circuit in this part, resistor and LED bulb to the collector, right? This is our LED bulb. So then we need the 270 ohm resistor here. So this is our 270 ohm resistor. We have to connect this 270 ohm resistor to the positive terminal. This is positive terminal, positive current, and I'm going to fix it here. And then we have LED bulb. This is the positive side of the LED bulb to this 270 ohm resistor. This is lengthy one is the positive. I'm going to fix this, right? Somewhere. So in this way, so the negative side should be connected to the collector terminal, right? Collector terminal of the transistor. Now I'm going to connect this, because in the middle line, right? And this one in the transistor collector, and the other side I will bring here, somewhere here. Okay, right. So look at this. There you can see the LED bulb. This terminal has been connected to the collector current, and the other side has been connected to in this line. So then you can provide this positive current to the resistor, and through the resistor to the LED bulb, right? Now we have completed the circuit, right? You can now check again your circuit whether you have completed it properly, right? Okay, let's go back to your circuit and check. Now consider the negative line. Negative line, you have negative line here coming here, then negative side of the capacitor is being connected. The other side of the capacitor is connected here. The side of the capacitor here. It is connected to the resistor here. This is the resistor, and the other side is for the this push button switch, and other side of the push button switch is positive current, right? So this is the positive line. I have connected this positive line to this one, right? Then this is the line is coming all the way here, and then you have this 270 ohm resistor. This is the positive line is coming here, and 270 ohm resistor. The other side of the resistor has been connected to the LED bulb, and this connection is here. Right? LED bulb. The other side of the LED bulb is connected to the collector. That means the middle pin of this transistor. Right here, it is that connection. Right? And then the base current here, base current has been, this base line, base here is connected to the resistor, in this resistor base one, right? So then the emitter current has been connected to negative wire, right? So then all the wiring is completed, right? Now you can remove this and fix the supply the current, right? Your battery pack, the wires, battery pack wire, right? Now I'm going to fix this, supply this current. So the negative one here and positive one here, positive line here, right? We have checked it, and I'm going to supply the current, right? Okay, now we have supplied the current, right? Now what we have to do is to press this push button switch. That means, so we have to connect this line together by observing this LED bulb, right? Let's see what happened. When I touch this, that means then you see the light bulb is lighting, right? Bulb. So then you can see that its brightness getting low and low and low, and finally fade away to the zero level. Right? Actually, sometimes you can't predict that whether it is switch or bulb is completely stop lighting or fully bright. Brightness getting little by little reduced, right? This is analog type signal, right? Large number of position is there. Now I can again I can press this push button switch. So here we have push button switch actually. So this one is push button switch. So you can use this push button switch, or otherwise you can just, this is push button switch. You can use this type of push button switch, or otherwise you can, this is the push button switch. So when you press it, the terminals provide it like this, right? So if I push, when I push this, you can see starting brightness, increase in the brightness, now gradually decrease in the brightness, right? Decrease in the brightness. So this is this circuit function, right? So you can complete this circuit and observe the function, right? Now you can see this is discrete amount of position, that means analog type signal. Now we are going to discuss a little bit about that how can we get on and off position, because it is very difficult to uh, count the time period and fill this table. This is operating time, because large number of brightness position. It is very difficult to guess in which time this bulb lighting has stopped, because we have to put this operating time here. Right? So to do this, we need to get this digital type signal from here, right? Bulb switch on and bulb switch off sometimes, right? So how can we do this? So we can do this by using a relay switch, right? Relay switch. So here, instead of this using instead of using resistor and LED bulb combination, we can replace this with a relay switch, right? So let's see how relay switch will work. So here you can see that in a relay switch, you have this electromagnet here, right? So we can replace this bulb and resistor combination with uh, this relay switch. Relay switch is we have here electric coil. When this base current is activated, there will be an electron flow here, and this coil will get current sufficiently, and then these metal plates, you can see the three metal plates. So then this become electromagnet, and then these levers, these metal strings will um, switch position will change there, right? So then when this become electromagnet, this bulb will start lighting because this connection will be established there, right? Once this the coil, the current coil through the coil is getting reduced to some critical point, and this connection will be reassembled, right? So the relay will position in previous position, right? Its previous position. That means switch off this bulb, right? So this actually these are mechanical items. When this it happened at once, right? So therefore you can see only two status, whether this metal plate in this connection or this connection, right? Metal plate, when the metal plate is in this position, this arrangement in the relay, so bulb will not light, right? So when this coil get electricity, that this lever will pull into this lever side, so then this connection will be established and bulb will light, right? So I will show you this in relay with relay switch here, right? So this is a relay switch. It sometimes relay switch comes like this. This is a relay switch, relay, and a relay switch, and you have different pin connections there. And in this one, actually, these two terminals for the coil, right? Electromagnet coil, and this one, the current input terminal. This terminal, once it will connected to this line. Other time, when this coil get electricity, this terminal will be connected to this one, right? Usually, this pin is connected to this one, but when the this two terminals get electricity, this connection will establish here, right? It is like a small lever here, like this, right? So when there is no electricity supply to this coil pin, so this lever is connected this way, right? So once these two terminal get electricity, this will turn like this and connected to this line, this terminal, right? So the using this one, I can explain you the function. So this is electromagnet coil, and coil connections are supplied to these two terminals. This is a different type of relay switch. The terminal in this switch is different to the one we previously saw. So here what happens is when this getting electricity, there is a lever here. The lever pull down, right? You can see this lever getting down. At the same time, this lever moving inside. This electrode is moving inside, right? When I press this, when this is connected to the electricity, this metal bar will push down, and this small plastic bracket push this terminal to forward direction. So then this connection will be established there, right? Now normally it is disconnected here, but this when this press, this move to the front and connection will be established, right? So this is the function. So this connection will be established when this when you in the circuit, when you just push and release the button, then this will get high amount of electricity, then the connection will be established, right? So then gradually the coil through this current through this coil will be reduced, and in some but this will hold until this electric current get some critical level. Once this electricity inside the coil reduced to some critical, less than some critical point, so then this will so it will not be able to hold further this lever. So then this will pull back and this connection will be again disconnect, right? So this is the way that it works. So now you are not advisable to use this relay switch, because relay switch we are going to replace this LED bulb and the resistor, this combination with relay switch, as well as relay switch with main electric bulb, right? Main 230 electric bulb. So you are not going to do this because it is dangerous. You are practicing that part. But I will connect this connect and show you how to do. Okay, here it is, that part, right? We have the electric bulb here, 230 bulb here, and then we have this electricity supply. This is electricity supply. This is electricity 230 electricity supply here, and then you have the other end, you have this bulb, right? So the switch wire, this is the switch wire. So the switch wire has been connected to this relay switch, right? So if these two connections are established, the bulb will light, right? So this current is from the main current is coming here, and the neutral line is directly connected to the bulb, and the live wire is coming all the way here, and it has been connected to this terminal, and this terminal is originally connected to this one, right? These two terminals, this one to this one. But when this relay switch, these two terminals, this blue and white color wire get electricity from our circuit, this become electromagnet, and then this line will be connected to this one, right? Then you can see the lighting of the bulb, right? Now what we have to do is we have to connect these two terminal to this we can replace this LED bulb, right? And the resistor combination, right? So then we are going to connect this circuit, this one to positive line, right? This is positive line directly connected, Okay, and the other one is to should be connected to the collector directly, the middle pin of the transistor. Okay, okay, we have connected it. Right. Now another thing is there that this to operate this relay switch we need little bit more current, right? It is not enough. This it is not sufficient. This 3 volt small batteries to operate this relay switch. So therefore we have to use little more current. So therefore to do this I am going to use a power supply. So you don't have this power supply, AC main power supply that you did with your practical at, in the department. Now I'm going to provide electricity and by using this one, right? So I'm going to remove this electricity supply here, normal battery pack, and connect our power supply, our AC power adapter, power supply to my circuit, right? So this is negative current from that, and then this is positive current, right, and connected. Okay, and now I am going to supply this current. I'm going to plug these two power supply and the electricity supply to the bulb by using extension wire. Okay, now the power has been connected to the bulb, so you can see the space is not sufficient. Okay, now you can we have the bulb already connected. We have our relay switch here. Now I'm going to change. Now I'm going to change the. Now I'm going to press this, right? I'm going to press the push button switch. That means I'm going to connect this. You see or observe the bulb, right? It is now lighting. It is switch off now, right? Again, I will press this. It's now lighting and switch off, right? So now I'm going to change my capacitor, right? This is 470 capacitor. Now I'm going to use 4000 microfarad capacitor instead of 470, right? Let's see what happened. Okay. Now I'm going to write. So the operating time is little bit long, right? than previous one. Now let's you can count, right? So this is starting time. It is quite the time is little bit longer than previous, right? And so let's change the 1K resistor, 1K resistor with 10K resistor. Then this is 10K resistor. I'm going to change this 1K resistor by 10K resistor. Let's see what happens. Right. So now I'm going to press this button switch. Right. Now you can see quite long duration. Bulb will operating quite some sort of long duration, right? Right. Again, I'm going to use 100K resistor here. Then you will get more time period. 100K resistor. And I'm going to press this push button switch again. You didn't get any response here, right? You didn't get response. Why? Because 100K resistor is too much, right? It is not enough to activate the base current. Let's say 50 ohm. 50 ohm, we don't have 50 ohm, but I will use this 100 ohm, two resistors there, right? What will happen? See what will happen. This is also not sufficient. Let's see 12K. Yeah, that is enough. Right? 12K. Quite lengthy time duration. Right? So that now you can count actually because only two positions, on or off. Right? Our electromechanical device, the relay switch, provided us this function. Right? Okay, this is what you are supposed to complete for this practical. So you come up with your these different. Now you have only purchased that's 47 microfarad, 470 microfarad and 1000 microfarad three capacitors and 1K, 10K and 100K resistors. So fix these resistors and capacitor combinations and you connect this circuit only with the LED bulb and resistor, and then you can actually observe that the operating time of LED getting higher and higher when you increase the capacitor as well as resistor value as well as the capacitor value, right? Okay, this is the practical. Then once you complete this practical, you can try to complete this practical as well, this one as well. If you have any question, you can contact me, email me, or phone, make a call, and I will give required instruction, right? Okay, have a nice time.